What if one wrong architectural decision in a safe environment could create expensive rework, slow down your teams, and put an entire solution at risk? That is why understanding the role of a safe architect is so important before you take the Certified Safe for Architects exam. In this complete study guide, we will cover all 6 sections and break down the key concepts, responsibilities, and lean agile principles you need to understand. A free study guide with the most important exam questions is available in the description, so make sure to check it out. Stay with me through the complete video because, at the end, I will also share a simple and practical approach that can help you prepare more effectively and pass the certification exam with confidence. So, let's get started and build your understanding step by step. To understand the safe architect role, we first need to look at how it differs from traditional architecture. In older predictive models, architects often worked in isolation, handing down massive design documents before any coding even began. This approach, known as big design up front, often led to bottlenecks and systems that were rigid and hard to change. A safe architect, on the other hand, works directly alongside the development teams, continuously evolving the architecture as new business requirements emerge. The Scaled Agile framework defines 3 specific types of architects to handle different levels of complexity. First, we have the enterprise architect, who aligns the overall technology strategy with the business goals of the entire portfolio. Next is the solution architect, who focuses on designing large, complex systems that require multiple release trains to build. Finally, there is the system architect, which is often the primary focus of this exam, who works at the agile release train level to guide the technical vision for teams delivering specific products. The system architect has a very unique and highly collaborative job description. You are not just drawing diagrams on a whiteboard, but instead, you are actively aligning the architectural strategy with the business features being developed. You provide a clear technical vision that helps agile teams understand how their specific pieces fit into the broader puzzle. This means you must carefully balance the need for architectural stability with the agile demand for rapid, continuous feature delivery. One of the most important concepts for the exam is the balance between intentional architecture and emergent design. Intentional architecture refers to the planned, foundational guidelines and structural guardrails that you establish to keep the system synchronized and scalable. Emergent design is the technical discovery that happens when agile teams actually write code, test features, and solve day-to-day problems. As a safe architect, you must provide enough intentional architecture to prevent chaos, while leaving enough room for emergent design to foster team innovation. The mechanism that supports this delicate balance is called the architectural runway. The architectural runway consists of the existing code, components, and technical infrastructure necessary to support the implementation of high-priority, near-term features. Think of it like paving a smooth road just in front of a moving car, ensuring the developers can drive forward quickly without having to stop and build the underlying infrastructure themselves. You will be tested on how to continuously build and maintain this runway without over-engineering it. Your decisions as an architect must always be grounded in the 10 safe lean agile principles. These principles are not just theoretical ideas, but highly practical tools that help you solve complex technical problems daily. They shift your mindset from focusing purely on technical perfection to focusing on delivering maximum economic value in the shortest sustainable lead time. Whenever you face a difficult exam question, filtering your choices through these 10 principles will often point you directly to the correct answer. The very first safe principle tells us to take an economic view. For an architect, this means every technical decision must be weighed against its financial impact, including development costs, maintenance overhead, and the cost of delay. You should never choose a shiny new technology simply because it is popular, but rather because it provides a clear economic advantage to the organization. Understanding the financial trade-offs of your architectural choices is a core competency heavily tested on the exam. The second principle, applying systems thinking, is incredibly relevant to your daily work. Systems thinking requires you to look at the entire organization, the full technology stack, and the complete delivery pipeline, rather than just isolated components. If you optimize one specific database query but ignore how it negatively impacts the overall user experience, you have failed to apply systems thinking. The exam will expect you to solve problems by looking at the bigger picture and understanding how different system boundaries interact. Another vital principle is to assume variability and preserve options. Traditional architecture tries to lock down every single detail early, which makes change very expensive later on. Agile architecture encourages you to keep your design options open for as long as possible, using concepts like set-based design. By delaying irreversible decisions until you have more concrete data, you reduce technical risk and make the entire system much more adaptable to shifting market demands. To validate your architectural decisions, you must build incrementally with fast, integrated learning cycles. Instead of waiting months to see if a new framework actually works, you create a small proof of concept and test it immediately in the real world. These fast feedback loops allow you to pivot quickly if your initial architectural assumptions turn out to be incorrect. The exam frequently tests your understanding of how to use integration points to measure the true health and viability of the system. Similarly, SAFe relies on basing milestones on the objective evaluation of working systems. In the past, progress was measured by completing design documents or passing phase gate reviews, which often hid massive amounts of technical debt. Now, your architectural progress is measured by actual, working software that can be demonstrated and evaluated by real stakeholders. This ensures that the architecture is functionally sound and actively supporting the features the business actually needs right now. As an architect, you also play a huge role in visualizing and limiting work in process, reducing batch sizes, and managing queue lengths. When technical teams try to redesign an entire system all at once, they create massive bottlenecks that slow down the entire release train. You must break large architectural initiatives into smaller, manageable chunks called enablers. By keeping these batches small, you help the teams deliver architectural value much faster and with significantly less risk. Applying cadence and synchronizing with cross-domain planning is how you align your technical work with the rest of the business. Cadence creates a predictable, steady rhythm for development, while synchronization ensures that all teams, including architects, are moving in the exact same direction at the same time. This principle is brought to life during program increment planning, where you will actively align the architectural runway with the upcoming business priorities. SAFe also emphasizes unlocking the intrinsic motivation of knowledge workers. This means architects are not dictators who hand down rigid instructions for developers to blindly follow. Instead, you act as a servant leader, providing context, explaining the technical vision, and giving teams the autonomy to find the best implementation details themselves. Trusting your developers and fostering a collaborative, supportive environment is a heavily tested concept in the leadership domain of the certification exam. A direct extension of empowering workers is the principle to decentralize decision-making. Strategic, long-term, and highly impactful decisions, like choosing a primary cloud computing provider, remain centralized with the architects. However, frequent, time-critical, and local decisions, like designing a specific class structure in the code, must be decentralized and handed over to the Agile teams. Understanding exactly which decisions to keep and which to delegate is a common scenario you will face on the test. The final Lean Agile principle tells us to organize around value. Your architecture should directly reflect and support the smooth flow of value through the organization's business streams. If your system design forces teams to constantly wait on other departments, or creates unnecessary manual handoffs, the architecture is actively blocking value delivery. The exam will expect you to design modular systems that allow Agile release trains to operate independently and deliver value with minimal friction. Embracing all of these principles transforms you into what SAFe calls a lean Agile leader. You lead by example, demonstrating a continuous learning mindset and a deep commitment to Agile values in everything you do. You must constantly educate business stakeholders on why technical investments are necessary for the long-term survival of the company. Your ability to communicate technical concepts in terms of business value is just as important as your ability to design a complex microservices architecture. As we wrap up these foundational concepts, remember that your ultimate goal as a SAFe architect is to enable the fast, continuous flow of value to the customer. You achieve this by balancing intentional architecture with emergent design, proactively building the architectural runway, and heavily relying on the 10 Lean Agile principles to guide your choices. Keeping this specific mindset at the forefront of your studies will make the more complex technical practices we cover later much easier to understand and apply. Congratulations on successfully completing the first section of this course. To truly lock in what you just learned, I highly encourage you to complete the attached practice test right now. Working through practice questions immediately after a lesson drastically improves your memory retention and builds serious exam readiness. This practice test is included with this lesson specifically to help you succeed, so please take full advantage of this active learning opportunity. Once you finish, I will see you in the next section where we will tackle architecting for continuous value flow and DevOps. Welcome back to the course. In this section, we are diving into architecting for continuous value flow and DevOps. You will learn how modern architecture acts as the engine for the continuous delivery pipeline, enabling organizations to release on demand. This is incredibly important because, without a supportive architecture, even the best Agile teams will face massive delays and deployment failures. Get ready to explore how technical design directly powers business agility, because this is where your role truly impacts the bottom line. To enable continuous value flow, we must first understand that software delivery is a continuous pipeline, not a series of isolated projects. The continuous delivery pipeline in SAFe consists of continuous exploration, continuous integration, continuous deployment, and release on demand. As a SAFe architect, your job is to ensure the system structure allows work to flow smoothly through all four of these phases without unnecessary technical friction. A foundational concept you will encounter on the exam is the CALMR approach to DevOps. CALMR stands for Culture, Automation, Lean Flow, Measurement, and Recovery. Architects play a massive role in all of these areas, particularly in designing systems that support heavy automation and quick recovery from inevitable failures. Whenever a test question asks about the DevOps mindset, always look for answers that align with these 5 principles. One of the biggest technical challenges in continuous delivery is the tight coupling of system components. If changing one small feature requires you to rebuild and redeploy an entire massive application, continuous deployment becomes impossible. The exam will test your ability to advocate for loosely coupled architectures, such as microservices, which allow Agile teams to develop, test, and deploy their specific components independently. To achieve this decoupled state, you will rely heavily on building the architectural runway through enablers. Enablers are technical items placed on the backlog to build infrastructure, explore new technologies, or improve the delivery pipeline itself. You must constantly work with product management to allocate enough capacity for these enablers, ensuring the runway is built just in time for the upcoming business features. During continuous integration, developers regularly merge their code changes into a central repository. Your architectural designs must support this practice by ensuring the code can be easily built, tested, and validated in an automated fashion. If the architecture is too complex or requires massive manual configuration for every test environment, you will break the integration cycle and slow down the entire release train. Designing for testability is another critical exam topic. If a system cannot be easily tested through automation, it cannot be safely deployed at speed. You need to design clear system interfaces, utilize mock objects, and separate the user interface from the business logic. By making the architecture inherently testable, you empower the development teams to create robust automated test suites that catch defects early in the pipeline. As code moves into continuous deployment, it is automatically pushed into the production environment, but it is not necessarily made visible to the users yet. To achieve this, architects heavily utilize feature toggles, which allow code to be deployed silently and turned on later with a simple configuration change. Understanding how to separate deployment from the actual business release is a major focus area for the certification exam. Release on demand is the ultimate goal, giving the business the power to make new features available to customers exactly when the market needs them. This requires an architecture that supports concepts like blue-green deployments or canary releases. A blue-green deployment keeps 2 identical production environments, allowing you to seamlessly switch user traffic to the new version with 0 downtime, completely eliminating the stress of traditional weekend launch events. To safely release on demand, you must have deep visibility into how the system is behaving in production. This brings us to the measurement aspect of CALMR, where architects must design systems with built-in telemetry, logging, and monitoring capabilities. If a new deployment causes a memory leak or a spike in error rates, the architecture should immediately alert the teams before the customers even notice. No system is perfect, which is why designing for recovery is absolutely essential. You must build resilient architectures that can gracefully handle component failures, network outages, or sudden traffic spikes without crashing the entire application. Concepts like the circuit breaker pattern, where the system automatically stops sending requests for a failing service to prevent a cascading disaster, are common scenarios you will see on the exam. To continuously improve this delivery pipeline, architects often participate in value stream mapping exercises. This process involves visualizing every single step, from a customer request all the way to the final delivery, to identify where the delays are happening. If the mapping reveals that manual security testing takes 3 weeks, your next architectural enabler should probably focus on automating that specific security check. Speaking of security, the exam will heavily emphasize the concept of DevSecOps, which integrates security practices directly into the daily DevOps workflow. Instead of treating security as a final audit at the end of the project, you must architect the system to include automated security checks in the local environments of your developers. This practice, known as shifting left, catches vulnerabilities early when they're cheapest and easiest to fix. Agile architecture also fundamentally changes how we handle databases. Traditional databases often become massive bottlenecks because schema changes require intense coordination and downtime. As a safe architect, you must explore evolutionary database design, utilizing techniques like automated database refactoring and version-controlled database scripts, allowing the data layer to evolve alongside the application code without breaking existing features. Modern continuous value flow relies heavily on cloud computing and infrastructure as code. Instead of waiting weeks for an operations team to manually configure a physical server, teams can spin up identical testing environments in minutes using code scripts. You will be expected to understand how leveraging cloud-native architectures, containerization, and virtualization drastically reduces deployment lead times and eliminates painful environment inconsistencies. A fascinating concept you need to know for the exam is Conway's Law. This law states that organizations design systems that mirror their own communication structures. If your company has 3 heavily siloed departments, you will likely end up with a disjointed, 3-tier architecture. As an architect, you must use the inverse Conway maneuver, organizing agile teams around the desired architectural boundaries to naturally produce better, more cohesive software. To ensure these different teams can communicate effectively, you should advocate for an API-first design strategy. Application programming interfaces act as clear, standardized contracts between different parts of the system. By defining these interfaces up front, independent teams can work on their respective components simultaneously without constantly stepping on each other's toes, vastly accelerating the flow of development. Throughout all of this, you must keep a sharp eye on technical debt. In the rush to deliver features quickly, teams sometimes take technical shortcuts that make the codebase messy and hard to maintain. While some technical debt is acceptable in the short term, you must ensure it is logged, tracked, and systematically paid down through continuous refactoring, otherwise the architectural runway will eventually collapse. In summary, your role in DevOps and continuous value flow is to remove technical friction at every possible stage. You are building the automated highways that allow code to travel safely from a developer's laptop directly into the hands of the customer. By designing for testability, utilizing feature toggles, shifting security left, and embracing modern cloud technologies, you enable the business to achieve true market agility. Congratulations on completing this section on architecting for continuous value flow and DevOps. To ensure these concepts stick, I strongly encourage you to take the attached practice test right now. Answering practice questions is the absolute best way to improve your memory retention and verify your exam readiness. This targeted practice test is included with this lesson to help you master the material, so jump in and practice active learning. Once you are done, I look forward to seeing you in the next section where we will align our architecture with program increment planning. Welcome back to the course. In this section, we are going to explore how architects align their work with program increment planning, commonly known as PI planning. You will learn the specific actions architects take before, during, and after this critical event to ensure Agile teams have a clear technical path forward. This topic is deeply important because PI planning is the heartbeat of the scaled Agile framework, and your technical guidance here prevents massive delays and team confusion. Get ready to master the coordination and planning skills that will make you an indispensable leader on any release train. PI planning is a cadence-based event that brings all the teams on an Agile release train together to plan their work for the next 8 to 12 weeks. As a safe architect, you do not just show up on the day of the event and improvise. Your work begins weeks in advance during a phase called PI planning preparation. The exam will heavily test your understanding of how proactive preparation ensures the teams can actually commit to realistic technical goals. One of your primary responsibilities before the event is to synthesize the technical vision. The technical vision provides a clear, inspiring picture of where the architecture is heading over the next few program increments. You need to communicate this vision in a way that developers easily understand and can translate into their daily work. Without a strong technical vision, teams will naturally drift in different directions, leading to disjointed systems and wasted effort. To support the upcoming business features, you must also define and prioritize architectural enablers. Remember that enablers build the architectural runway. During preparation, you work closely with product management to review the top 10 features coming into the planning event and determine what underlying infrastructure those features require. If the runway is not prepared in advance, the teams will struggle to deliver those business features on time. You will also collaborate with business owners to ensure that technical investments are given proper priority in the program backlog. Sometimes, business leaders only want to focus on customer-facing features, completely ignoring necessary technical upgrades. A key skill tested on the exam is your ability to explain the cost of delaying architectural work. You must translate technical debt and infrastructure needs into business risks that stakeholders can clearly understand. When the actual PI planning event begins, you take on a highly visible leadership role. On the very first morning, you will stand in front of the entire release train and present the architecture vision and development practices. This presentation is your opportunity to highlight new technologies, explain upcoming architectural shifts, and set the technical guardrails for the increment. Your goal is to inspire the teams and give them the context they need to plan effectively. As the teams move into their breakout sessions to create their individual plans, you do not sit back and relax. Instead, you constantly roam between the team areas acting as a technical consultant. When teams encounter complex design problems or realize they are missing a critical piece of infrastructure, they will call on you for guidance. The exam expects you to act as a servant leader during these breakouts, helping teams find solutions without dictating every minor technical detail. Managing dependencies is another massive part of your role during PI planning. Because complex systems require teams to work together, Team A might need an application programming interface built by Team B before they can finish their feature. You must help the teams identify these technical dependencies early in the planning process. By visualizing these connections, usually on a large program board, you ensure the architecture does not become a tangled web of delays. Sometimes, teams will identify technical risks during their planning breakouts that could jeopardize the entire program increment. SAFe uses a specific technique called ROAM to handle these risks. ROAM stands for resolved, owned, accepted, or mitigated. As an architect, you will often take ownership of deep technical risks, committing to investigate a new tool or build a quick prototype to mitigate the danger before it impacts the delivery schedule. You will also help teams balance their capacity between business features and technical enablers. A common exam scenario involves a team that wants to spend all their time building new features, completely ignoring the technical debt they accumulated in the last increment. You must gently guide them to allocate a healthy percentage of their capacity, often around 20 to 30%, specifically for refactoring and extending the architectural runway. On the second day of PI planning, the teams present their final plans, and business owners assign business value to the objectives. While you do not assign the business value yourself, you play a critical role in helping the owners understand the value of technical objectives. You must clearly explain how upgrading a database or improving security protocols directly protects the business and enables future growth. PI planning concludes with a confidence vote, where everyone on the train indicates how confident they are in achieving the plan. If confidence is low due to architectural uncertainty, you must step in immediately. You might need to adjust the technical scope, propose a simpler design alternative, or promise additional architectural support during the execution phase. The exam expects you to be a proactive problem solver when technical doubts arise. After PI planning is over and the teams begin executing the increment, your focus shifts to guiding the implementation. You participate in regular synchronization meetings, often called art syncs or system demos, to monitor the health of the architectural runway. If a team discovers that an initial design is completely failing in the real world, you must help them pivot quickly, utilizing the principle of emergent design. During execution, you will also continuously refine the architectural runway for the next program increment. This means the cycle of preparation never truly stops. While the teams are building the current features, you're already looking ahead, analyzing the next batch of business requests and designing the enablers needed to support them. This continuous forward-looking mindset is a hallmark of a mature, safe architect. A very practical tool you will use to manage this continuous flow of architectural work is the architectural Kanban. This visual board helps you track the progress of massive technical initiatives from initial ideas to fully implemented solutions. By visualizing the architectural work, you can apply work in process limits, ensuring that you and your fellow architects are not trying to design too many complex systems at the exact same time. Another concept the exam heavily focuses on is the system demo, which happens at the end of every 2-week iteration. The system demo requires the teams to integrate all their work and show a fully functioning system. For the architect, this is the ultimate test of your design. If the teams cannot integrate their code, or if the system constantly crashes during the demo, it is a glaring signal that the architecture is too tightly coupled or fragile. To ensure smooth integration, you must establish clear integration points and mandate continuous integration practices. You cannot wait until the end of the program increment to see if the pieces fit together. You must architect the system so that teams can integrate their code daily, or even hourly. This constant validation provides the fast feedback loops necessary to correct architectural mistakes before they become deeply embedded in the product. Finally, you will participate in the Inspect and Adapt event at the end of every program increment. This is a dedicated time to reflect on what went well and what failed structurally. If the architectural runway was insufficient and caused major delays, you must lead a root cause analysis to figure out why. The exam will test your ability to use these reflection periods to continuously improve the architectural practices of the entire release train. In summary, your role in PI planning spans from deep preparation to active facilitation and continuous follow-through. You are the bridge between the high-level business strategy and the ground-level technical execution. By clearly communicating the technical vision, managing complex dependencies, mitigating architectural risks, and ensuring smooth integration, you empower the Agile teams to confidently deliver massive value every single increment. Congratulations on completing this section on aligning architecture with program increment planning. To make sure these critical planning concepts stay fresh in your mind, please take a few minutes to complete the attached practice test right now. Working through practice questions immediately is a proven way to drastically improve your retention and prepare you for the real exam scenarios. This test is included specifically to boost your confidence, so dive into that active learning. Once you are finished, I look forward to seeing you in the next section where we will tackle designing solutions with quality and non-functional requirements. Welcome back to the course. In this section, we are going to focus on designing solutions with quality and non-functional requirements. You will learn how to build quality directly into the system from the very beginning, rather than trying to test it in at the end. This is a vital topic because even the most feature-rich application is useless if it is slow, insecure, or constantly crashing. Get ready to explore how architects define the rules of the system, ensuring that everything we build is robust, reliable, and ready for the real world. The concept of built-in quality is a core value in the scaled Agile framework. It means that quality is not an afterthought handled by a separate testing team right before a release. Instead, as an architect, you must ensure that quality standards are baked into every step of the development process. You do this by establishing clear coding standards, promoting test-driven development, and ensuring the architecture naturally supports automated validation. To enforce this quality, We rely heavily on non-functional requirements, commonly referred to as NFRs. While functional requirements describe what the system should do, like allowing a user to log in, non-functional requirements describe how well the system should do it. These include critical attributes like performance, security, reliability, scalability, and usability. On the exam, you will frequently be asked how to handle these hidden requirements that define the overall health of the application. It is helpful to think of non-functional requirements as constraints on the system design. If a business owner requests a new reporting feature, the functional requirement is simply generating the report. However, your non-functional requirements might dictate that the report must generate in under 2 seconds and handle concurrent requests from 5,000 users. These architectural constraints drastically change how the development teams will choose to build that specific feature. A common exam question asks where these non-functional requirements actually live within the Agile backlog. Unlike standard business features, NFRs are not usually standalone items that you build and then mark as done. Instead, they act as persistent constraints attached to the backlog itself, often residing in the definition of done. This ensures that every single user story and feature must pass these continuous quality checks before being accepted by the product owner. Testing non-functional requirements can be incredibly challenging, which is why your architecture must support automated compliance. If a system requires high security, you cannot rely on manual security audits once a year. You must design the deployment pipeline to include automated penetration testing and static code analysis. By automating these checks, you guarantee that every new piece of code respects the non-functional constraints without slowing down the release train. To manage all of this complex technical information, SAFe utilizes a concept called solution intent. Solution intent is the single source of truth regarding the current and intended behavior of the solution being built. It houses the vision, the architectural designs, the non-functional requirements, and the traceability links between them. As a SAFe architect, you are one of the primary custodians of this critical knowledge repository. Solution intent is divided into 2 distinct categories, which are fixed intent and variable intent. Fixed intent represents the things we know for absolutely certain, such as strict regulatory compliance laws or mandatory security protocols that cannot be changed. Variable intent represents the areas where we are still exploring options, such as the exact user interface design or the final choice of a database provider. The exam tests your ability to navigate the transition from variable to fixed intent over time. A key strategy in managing variable intent is to assume variability and preserve options. Early in a project, you might not know if a relational database or a document database is the better choice for a new application. Instead of forcing a premature decision, you keep both options open in the variable solution intent while the teams run small experiments. Once the teams gather empirical data, you can confidently move the winning choice into the fixed intent repository. Another vital function of solution intent is providing traceability. In highly regulated industries like healthcare or aerospace, you must prove that every line of code traces back to a specific requirement and a passing test. Your architecture must support tools and practices that automatically link requirements, design specifications, and test results together. This traceability proves to auditors that the system meets all necessary compliance and quality standards. Balancing solution intent requires a deep understanding of intentional architecture versus emergent design. As we discussed earlier, intentional architecture provides the structural guardrails, while emergent design allows teams to adapt locally. Solution intent is where this balance is documented and communicated. You provide the intentional non-functional requirements and structural diagrams as fixed intent, while the teams contribute their emergent discoveries back into the repository as they learn. To maintain high quality over time, architects must strongly advocate for continuous refactoring. Refactoring is the process of improving the internal structure of the code without changing its external behavior. As emergent design happens, the codebase can sometimes become messy or inefficient. You must help product management understand that dedicating time to refactor the code is not wasted effort, but a necessary practice to keep the system clean and maintainable. When teams ignore refactoring and bypass non-functional requirements to meet a tight deadline, they accumulate technical debt. Just like financial debt, technical debt accrues interest over time, making every future change slower and more expensive to implement. The exam expects you to know how to make technical debt highly visible to the business. You must quantify the cost of this debt and negotiate capacity in the backlog to systematically pay it down. You must also ensure that the system architecture actively prevents teams from violating quality standards. For example, if system reliability is a primary non-functional requirement, you should architect the application using redundant microservices. If one service fails, the others take over immediately, ensuring the user experience is zero downtime. By designing fault tolerance directly into the system, you make it easy for teams to meet the reliability constraints. Quality is further ensured by utilizing Agile testing practices across the entire development lifecycle. The Agile testing framework categorizes tests into unit tests, component tests, system tests, and exploratory tests. As an architect, you focus heavily on the structural and performance-based system tests, ensuring the infrastructure can handle extreme loads. You provide the environments and the tools that allow testers to push the system to its breaking point safely. A major theme in modern quality assurance is the concept of shifting left. This simply means moving testing, security, and performance checks as early in the development process as possible. Instead of waiting until a feature is fully built to test its performance, you architect local development environments that simulate production loads. This allows developers to catch and fix architectural violations on their own laptops before the code is ever merged. For organizations dealing with strict regulations, compliance is often the most critical non-functional requirement. SAFe provides a lean approach to compliance, moving away from massive phase gate audits at the end of a project. Instead, compliance checks are integrated into the continuous delivery pipeline. You must work closely with compliance officers to automate their regulatory checks, proving that continuous delivery can actually be safer and more compliant than traditional waterfall methods. In highly complex environments, like building physical hardware alongside software, architects often use model-based systems engineering to manage quality. This involves creating digital models of the system to simulate behavior before any physical components are ever built. By testing the digital model against the non-functional requirements, you can discover massive architectural flaws incredibly early. The exam may ask how these modeling techniques reduce technical risk and improve overall solution quality. Ultimately, your role in designing solutions is to make doing the right thing the easiest thing to do. By clearly defining non-functional requirements, managing the solution intent, enforcing built-in quality, and advocating for continuous refactoring, you protect the long-term viability of the product. You ensure that the Agile teams are not just building software fast, but are building excellent, secure, and scalable software that truly delights the customer. Congratulations on finishing this crucial section on quality and non-functional requirements. To lock these concepts into your long-term memory, please jump into the attached practice test right away. Answering practice questions builds your exam readiness and highlights any areas where you might need a quick review. This practice test is included right here with the lesson to maximize your active learning. Once you complete the test, I will see you in the next section where we will explore strategic themes and portfolio architecture. Welcome back to the course. In this section, we are zooming out to view the entire organization by exploring strategic themes, value streams, and portfolio architecture. You will learn how high-level enterprise goals directly influence the technical decisions we make on the ground. This is incredibly important because if your architecture does not align with the overarching business strategy, you end up building beautiful systems that the company does not actually need. Get ready to elevate your perspective as we transition from team-level design to enterprise-level technical leadership. To understand portfolio architecture, we first need to introduce lean portfolio management. In traditional companies, centralized management often hands down strict annual budgets and rigid project plans. In a safe environment, lean portfolio management takes a much more agile approach, aligning strategy and funding directly with value delivery. As an architect operating at this level, you will collaborate closely with portfolio managers to ensure that long-term technical investments are properly funded and prioritized. The primary tool used to connect enterprise strategy to the portfolio is called a strategic theme. Strategic themes are simple, memorable phrases that define the future direction of the business, such as transitioning to a cloud-first infrastructure or expanding into the mobile gaming market. For the exam, you must understand that these themes act as a massive filter for every architectural decision. If a proposed technical initiative does not actively support at least one strategic theme, it should not receive funding or attention. Because strategic themes guide the entire portfolio, they drastically influence the architectural runway. If a strategic theme dictates a shift toward artificial intelligence, the enterprise architects must immediately begin planning the underlying infrastructure to support machine learning models. You must constantly monitor these high-level themes to anticipate what the Agile release trains will need 6 to 12 months from now, ensuring the runway is built long before the business features are requested. Another foundational concept at the portfolio level is the value stream. A value stream represents the exact sequence of steps an organization takes to deliver a product or service to a customer. Understanding these streams is critical because the primary goal of SAFe is to optimize the flow of value from end to end. If you do not understand how your company actually makes money or serves its users, you cannot design an architecture that accelerates that specific process. The exam will expect you to differentiate between operational value streams and development value streams. An operational value stream includes the steps used to deliver value to the end customer, like a patient receiving treatment at a hospital or a shopper buying a pair of shoes online. A development value stream represents the teams and systems that build the software supporting that operational flow. As an architect, your job is to design the systems within the development value stream to perfectly support the operational business goals. Mapping these value streams is a highly visual and revealing exercise. When architects map the systems supporting different value streams, they often uncover massive bottlenecks. For example, you might discover that 3 distinct value streams all rely on the exact same legacy database, creating a severe traffic jam every time a deployment happens. Identifying these structural constraints allows you to design enablers that decouple the systems and restore a smooth flow of value. To capture the current state and future vision of these value streams, the organization uses a portfolio canvas. The portfolio canvas is a visual template that outlines the value propositions, key partnerships, budget allocations, and necessary resources for the entire portfolio. As an enterprise architect, you will directly contribute to this canvas, specifically focusing on the technical resources, software licenses, and infrastructure partnerships required to keep the portfolio running smoothly. When a strategic theme requires a massive technical change, it is captured as an epic. Epics are enterprise-level initiatives that are so large they require multiple program increments and multiple release trains to complete. Architects are directly responsible for writing and guiding enabler epics, which are massive technical upgrades, like migrating an entire data center to the cloud. You will need to know how to manage these epics as they flow through the portfolio Kanban board. Before an enabler epic is fully funded, it must have a clear epic hypothesis statement. This statement defines the expected business benefits of the technical upgrade and how you will measure success. More importantly, it requires you to define a minimum viable product to test the hypothesis early. Instead of migrating the entire company to the cloud all at once, you might migrate one small application first to prove the concept, reducing massive financial risk. To convince business owners to fund your technical epic, you will help create a lean business case. Traditional business cases are massive, 50-page documents filled with fictional financial projections. A lean business case is short, focused, and highlights the cost of delay, the anticipated return on investment, and the strategic alignment of the technical work. The exam will test your ability to speak the language of business leaders to secure funding for critical architectural improvements. Funding in SAFE is handled through a collaborative process called participatory budgeting. Instead of executives deciding budgets behind closed doors, stakeholders from across the portfolio come together to distribute funds among various value streams. As an architect, you must actively participate in this event to advocate for technical investments. You must clearly explain why allocating budget to security upgrades or system modernization is just as important as funding new customer features. At this level, the role of the enterprise architect becomes highly distinct from the system architect. While a system architect focuses on a specific release train, the enterprise architect looks for synergies across multiple value streams. You might notice that 3 different release trains are all building their own custom payment gateways. The enterprise architect steps in to standardize a single, shared payment service, saving the company massive amounts of time and money. However, driving this standardization requires a very delicate balance. If you force too much standardization, you strip the Agile teams of their autonomy and slow them down with bureaucratic rules. If you allow too much autonomy, you end up with a chaotic portfolio filled with duplicate tools and incompatible systems. Navigating this tension between portfolio standardization and team-level freedom is a sophisticated leadership skill frequently tested on the exam. To maintain this balance, you must absolutely avoid becoming an ivory tower architect. Ivory tower architects sit in separate offices, completely disconnected from the actual code, handing down mandates that do not work in the real world. In SAFE, enterprise architects must actively engage with the Agile release trains, listening to feedback from developers and adjusting the portfolio strategy based on ground-level technical realities. When complex systems span across multiple value streams, you are responsible for value stream coordination. If a major strategic theme requires the mobile app team and the main back-end team to release a synchronized update, you must ensure their architectural interfaces are perfectly aligned. You design the integration points and API contracts that allow these separate value streams to collaborate without becoming tightly coupled or blocking each other's progress. To prove that your architectural strategy is actually working, you must rely on lean metrics rather than subjective opinions. You will track metrics like lead time, cycle time, and flow efficiency across the entire portfolio. If a massive new architectural framework is introduced and the average cycle time for the release trains suddenly doubles, the data is telling you the architecture is failing. You must use these objective metrics to continuously pivot and improve the portfolio design. Ultimately, the goal of portfolio architecture is to enable true strategic agility for the organization. Strategic agility means the company can rapidly pivot its entire business model in response to sudden market changes, like a global pandemic or a disruptive new competitor. An organization can only achieve this level of agility if the underlying architecture is modular, decoupled, and designed for continuous change from the very beginning. In summary, your role at the portfolio level connects the highest business strategies with the deepest technical realities. By understanding strategic themes, mapping value streams, writing lean business cases for enabler epics, and participating in agile budgeting, you ensure the entire enterprise moves in a unified direction. You become a strategic partner to the business executives, proving that excellent architecture is a primary driver of financial success. Congratulations on completing this advanced section on strategic themes and portfolio architecture. To reinforce everything you just absorbed, I highly encourage you to complete the attached practice test right now. Working through these practice questions will solidify your understanding of these complex enterprise concepts and vastly improve your exam readiness. This test is included specifically to help you succeed, so please engage in that active learning. Once you finish, I will see you in our final section where we will focus on leading architectural change. Welcome to the final section of our course. In this lesson, we are going to explore the critical leadership skills necessary for leading architectural change and guiding enterprise transformation. You will learn how to shift from dictating technical rules to actively coaching and inspiring agile teams. This topic is incredibly important because even the most brilliant architectural design will fail if you cannot convince the people around you to actually build it. Get ready to discover how to use influence, empathy, and lean agile leadership to drive massive technical success across your entire organization. The transition from a traditional architect to a safe architect requires a profound shift in how you view authority. In the past, architects often relied on their job title to force developers to follow strict design documents. In an agile environment, that top-down approach completely destroys team morale and slows down value delivery. The exam will heavily test your understanding that a safe architect operates as a servant leader, focusing on supporting the teams rather than commanding them. Acting as a lean agile leader means you must deeply internalize and demonstrate the safe core values every single day. These values include alignment, transparency, respect for people, and relentless improvement. When you make architectural decisions, you must be completely transparent about why those choices were made and the data you used to make them. By modeling these behaviors yourself, you create a culture of trust where developers feel comfortable approaching you with their technical challenges. A massive part of this cultural shift involves establishing psychological safety within your technical teams. Psychological safety means that developers feel safe to experiment, ask questions, and even make mistakes without fear of punishment or ridicule. If an agile team tries a new architectural pattern and it fails, you must treat it as a valuable learning opportunity, not a punishable offense. The exam expects you to know how to foster an environment where continuous learning is celebrated over flawless execution. To build the capabilities of your teams, you must become an active coach and mentor. You cannot just hand a complex design to a junior developer and expect perfect results. You need to sit down with them, perhaps using pair programming techniques, to explain the nuances of the architecture in real time. By continuously upgrading the technical skills of the people around you, you ensure that the entire release train becomes more self-sufficient and capable of handling complex challenges. Because you do not have direct managerial authority over the agile teams, you must master the art of influencing without authority. To get people on board with your technical vision, you must rely on data, logical reasoning, and active listening. When you propose a massive infrastructure upgrade, you must be able to explain how it specifically makes the daily lives of the developers easier. If they see that your architecture removes their frustrations, they will willingly follow your lead. A simple but incredibly powerful leadership technique is to always explain the why behind your architectural decisions. If you just tell a team what to build, they will likely build it poorly because they lack the necessary context. However, if you explain why the business needs a highly scalable microservice to handle an upcoming marketing campaign, the team can use their own creativity to build the best possible solution. Providing this context is a key characteristic of decentralized decision-making. As an architect, you are also a primary change agent for the entire organizational transformation. Moving to SAFe is often difficult and disruptive, and people will naturally resist the new ways of working. You will frequently collaborate with the Lean Agile Center of Excellence, which is the internal group guiding the SAFe rollout, to champion the transformation. You must advocate for agile practices, defend the need for continuous integration, and patiently explain the benefits of the framework to skeptical traditional managers. Overcoming resistance to change requires a deep sense of empathy. When a senior database administrator pushes back against your proposal to automate database deployments, you must understand their underlying fear. They might be worried about losing control, compromising data security, or even losing their job. Instead of arguing, you must listen to their concerns, validate their expertise, and work together to design automated safety checks that make them feel secure in the new process. To scale architectural knowledge across a massive enterprise, you should actively establish and foster communities of practice. A community of practice is a voluntary group of people who share a passion for a specific technical domain, such as cloud security or front-end development. As a leader, you organize these groups, facilitate their meetings, and use them to share best practices across different release trains. This prevents teams from working in isolated silos and drastically accelerates organizational learning. You also play a vital role in creating a continuous learning culture. This means actively encouraging innovation and giving teams the time and space to explore new technologies. Many organizations use innovation and planning iterations to host internal hackathons, where developers can build prototypes using experimental architectures. By supporting these creative events, you help the company discover breakthrough technical solutions that might have been ignored during normal, fast-paced feature development. To truly understand how your architectural designs are performing in the real world, you must practice the lean concept of going to the Gemba. Gemba is a Japanese term that means the real place where the work is actually done. Instead of analyzing system performance from a distant office, you must occasionally sit directly with the Agile teams and observe them writing code or deploying software. Seeing their daily technical struggles firsthand is the most effective way to identify critical architectural bottlenecks. During the Inspect and Adapt event at the end of every program increment, your leadership is absolutely essential. When a major technical failure occurs, it is very easy for traditional managers to start blaming individual developers. As a lean Agile leader, you must steer the root cause analysis away from personal blame and focus entirely on the systemic issues. You must ask how the architecture failed to prevent the error, and then guide the teams to design structural improvements to ensure it never happens again. Another important aspect of guiding transformation is helping the organization manage cognitive load. Modern software development is incredibly complex, and if you force every team to understand every single part of a massive system, they will become overwhelmed and slow down. You must architect the system into clear, manageable domains, allowing specific teams to become experts in their specific areas. Keeping the architecture simple and aligned with team capacity is a highly effective way to boost productivity and morale. As you decentralize decision-making, you must establish clear, sensible guardrails. Decentralization does not mean absolute chaos where every team uses a different programming language. You define the boundaries, such as requiring all services to be deployed via a specific cloud provider, but you leave the internal service design up to the teams. Managing this delicate balance between enterprise consistency and team-level freedom is what separates a good architect from a great one. You must also maintain a strong, continuous dialogue with product management and business owners. Technical leadership means you never let the business strategy and the technical strategy drift apart. You must regularly translate complex architectural metrics into simple business language, proving that your technical investments are paying off. When business leaders trust your judgment, they will enthusiastically fund the enablers required to keep the architectural runway healthy. Sustaining architectural health over the long term requires relentless vigilance. As teams rush to deliver features, technical debt will naturally creep into the system. Your role as a leader is to ensure this debt is never ignored or hidden. You must champion the continuous refactoring of code and the retirement of outdated legacy systems. Teaching the organization to regularly clean up its architecture ensures that the company remains agile and competitive for years to come. Finally, you must remember to celebrate technical successes. When a team successfully completes a massive, difficult architectural enabler, or when a developer figures out a way to cut deployment times in half, you must publicly recognize their effort. Positive reinforcement builds a culture of pride and craftsmanship. When people feel that their technical excellence is seen and valued by leadership, they will naturally strive to produce higher quality work. Bringing it all together, your journey as a safe architect requires you to be a master of technology, a strategic business partner, and a highly empathetic leader. You are the visionary who designs the systems, the coach who empowers the teams, and the change agent who transforms the entire organization. By embracing the lean agile mindset and focusing on continuous value flow, you become the driving force behind the enterprise's long-term success. Congratulations on successfully completing this final section and the entire course material. To solidify your mastery of these leadership concepts and everything we have covered, I strongly encourage you to take the attached practice test right now. Completing practice questions is the ultimate way to boost your retention and guarantee your exam readiness. This comprehensive practice test is included to ensure you are fully prepared, so please take advantage of it. You have put in the hard work, and you are now ready to naturally transition to your next step, which is confidently passing your certification exam.